Now, this is another example of using Hess's law in relation to heats of reaction. And in this case here, we're asked to do three things. We're asked to write a balanced equation, then we're given some information, and then we're told to calculate. Okay, so let's follow the three parts of this question down as they're given. First part, write a balanced chemical equation for the combustion of ethanol C2H5OH. Now, first of all, what does combustion mean? Combustion is the chemical process by which you add oxygen to a substance. Sometimes we call it burning if it produces a decent flame. Other times we just call it chemical combustion when we're adding oxygen. And because we are adding oxygen to C2H5OH, then we've got to remember the only things that can be produced by adding oxygen to hydrogen is carbon dioxide and water. In fact, that's a general rule. Any single time you ever combust an organic substance with oxygen, the only two products can be carbon dioxide and water. Just keep that in mind. So anytime we burn an organic compound, we get carbon dioxide and we get water. Now, write a balanced chemical equation. So let's ask ourselves, is this balanced? Well, we've got two carbons and we've got one carbon. So I'm going to put a 2 in front of that there. Then we have 5 and 1 is 6. So I need 6 hydrogens. So I'm going to put a 3 here. And then I need, what have I got? 2 2s are 4 and 3 is 7. So 2 2s are 4. That's 4 oxygens here and 3. That's 7. So I need 7 over here altogether. There's 1. So that means 6 should be here. So a 3 in front of that. And that is the balanced equation for the combustion of ethanol. Okay. Now, let's see what we're told next. Given that the heats of formation of ethanol, carbon dioxide and water are minus 278, minus 394 and minus 26, calculate the heat of combustion of ethanol. So let's go through that 5-stage process of using Hess's law. Number 1, write down what you are required to find. What are you required to calculate? Well, we are required to calculate the heat of combustion of ethanol. Now, what is the heat of combustion of ethanol? The heat of combustion of ethanol is the heat change that takes place when 1 mole of ethanol is burnt in oxygen. Well, guess what? Look at what you've just written down in terms of the first part of your answer. Write down a balanced chemical equation for the combustion of ethanol. Let's just take a look at that. Is that equation there representative of the heat of combustion? Well, go through the definition one more time. It is the heat change that takes place when 1 mole of ethanol is burnt in excess oxygen. So guess what? That is the equation that I want to get the heat of. So I want to work out the heat change for that chemical reaction. So that's what I'm going to aim towards. Now, I need my Lego set, so to speak, and that's going to be in line 2. The heat of formation of ethanol, carbon dioxide, and water. So now you've got to go back to your heat of formation definition. It is the heat change that takes place when 1 mole of a substance is formed from its elements. So if I want to get the heat of formation of ethanol, listen carefully. It's the heat change that takes place when 1 mole of ethanol is formed from its elements. So what elements are present in here? Well, carbon is present, hydrogen is present, and oxygen is present. And please remember that being formed from your elements means that carbon, hydrogen, and oxygen must be written in their elemental states. And all bar carbon are diatomic. Hydrogen exists as H2 in its elemental form. Oxygen exists as O2 in its elemental form. Carbon is just C. Okay. Now let's balance this thing. What are we told first of all? Before we balance it, we're told delta H for this reaction. So the heat of formation of ethanol, carbon dioxide and water are minus 278, minus 394 and minus 26 respectively. So that means the first one belongs to ethanol, which is minus 278. Okay, now balance it before we move on. You're not allowed to touch the right hand side because the heat of formation says that only 1 mole is allowed to be formed from its elements. So I can only balance the left hand side. I need 2 carbons to match the 2 carbons here. I want 6 hydrogens, so a 3 there, and I want 1 oxygen, so a half there. Now, if this was chemistry, the half would not be very welcome. But because Hess's law is a mathematical exercise, we're going to put the half in just to make sure that it's balanced according to the mathematical needs that we have. Okay, the next one, heat of formation of carbon dioxide. It is the heat change that takes place when 1 mole of CO2 is formed from its elements. And the lovely thing about carbon dioxide is it's a self-balancing equation. No attention needed to it whatsoever. Minus 394. And then it says the heat of formation of water. Go through the definition again. It's the heat change that takes place when 1 mole of water is formed from its elements, H2 and O2. Now just remember that if I'm making 1 mole of water, I need a half a mole of oxygen to keep it balanced. Not allowed to balance the right hand side, only allowed to balance the left hand side. And delta H for that reaction is minus 286. Okay, so that is my playground. They're my Lego pieces. From there, I need to take the parts that I require to build this reaction up here. Okay, and that's what I'm looking to build. All right, let's go through the process. Number 1, are the required parts in the correct position in my Lego set? And very quickly you'll discover that C2H5OH is needed on the left hand side of the arrow, but down here in my Lego set it's C2H5OH, it's on the right hand side. So one of the first things I'm going to have to do here is I'm going to have to reverse that reaction, like so, and put down C2H5OH contains the elements 2C, 3H2, and a half an O2. Okay, and once you reverse the flow of the chemical equation, you have to reverse the flow of the energy. So it becomes plus. Okay, next one, I require 3 oxygens. Now I've got an unusual setup here, so I'm not going to touch that just yet. Okay, I've got 3, I require 3, but I've got 1.5. So let's just leave the oxygens, they're awkward. Move on to the carbon dioxide. Carbon dioxide, I require 2 of them. In my Lego set, I've only got 1. So I'm going to multiply this equation here by 2 to give me 2 of them, 2 of them, 2 of them, and twice the energy. So 394 times 2. 394 times 2. That's 788. So instead of that, 788. Okay. And lastly then, I need 3 H2Os, which means I have to multiply this equation here by 3. 3 of them, 3 halves is 1.5, and then 3 of them, and again 3 times the energy, and that comes out as 858. Okay, so if I've done this correctly, if I have aligned the pieces of my Lego set to match the equation I want to build, if I have brought the values, the quantities, up to the quantities I require, now what I do not require should cancel. So let's do that in blue. So first of all, what do I require? I do require the C2H5OH. I do require 3 oxygens. Now look at what I have. I've got 2 and 1.5. I've got 3.5. However, that half there will cancel with that half. See? So they're gone. I want 2 carbon dioxides, which I have, and I want 3 waters, which I have. Now everything else should cancel. So 2 carbons on the right hand side cancel with 2 carbons on the left. 3 hydrogens on the right hand side cancel with 3 hydrogens on the left. And what is left should be exactly what I need to build my equation. So what we do now is we write down what's left over on both sides. What's left over here? C2H5OH, and what? 2 and 1, 3 O2s. Go over to give 2 CO2 and 3 H2O, and delta H for this reaction is simply whatever your calculator tells you when you put in 278 and take away from that 788 and take away from that 858. And the answer comes out as minus 1368 kilojoules per mole. And that is the heat of combustion of ethanol. So look, again, I want you to go through that without looking at my solutions. Look at my solutions, learn what I'm doing, then go back, clear the solutions if you can, and go back to the equation and try it again. Pause the video on the initial box with the text in it and try it yourselves. In Google Classroom, I'm going to put up another 6 or 7 questions based on this that I want you to try yourselves. We'll have a live class then to go through them to make sure that this is okay with everybody. And then we're going to have a quick test on this chapter to make sure that all the thermochemistry is in your head. And then from there, that ends our 5th year course. We're done. We're going to start some revision on maybe the topics that need a little bit of work before we hit you with the summer exam.